This is problem 17 from chapter 26. The problem reads, light in a vacuum is incident on a transparent glass slab. The angle of incidence is 35 degrees. The slab is then immersed in a pool of liquid. When the angle of incidence for the light striking the slab is 20.3 degrees, the angle of refraction for the light entering the slab is the same as when the slab was in a vacuum. What is the index of refraction of the liquid? Okay, alright, so first thing we need to establish are the equations we'll be using in this question, and we'll solely be using Snell's law, which is n1 sine theta 1 equals n2 sine theta 2. And here I just have the given, which is our initial angle of incidence, which is 35 degrees. So the first step was for me to set up the first portion of the problem, which states that essentially, which is the relationship between the speed of light, the speed of the light in the vacuum as it goes from the vacuum to the glass. So we have NV sine 35 because that's our initial angle of incidence, and we have NG, which is the index of refraction of the glass, times sine theta G, which is the refractive angle in the glass. This next part of the problem, we have NW, which is the index of refraction of the water, times sine 20.3, which is said to be the angle, angle of refraction, but that is also with the glass, so equals the index of refraction of the glass times sine theta of the glass. The next part of the equation involves us actually combining the equations. Since both of these have a like term, we can conclude that NV sine 35 is equal to the index of refraction of the water times the sine of 20.3, which is the angle of refraction in the water. And as we know, we're solving for the index of refraction of the water in this problem. So what we would ultimately do is just algebra. We divide over the sine of 20.3 from both sides. So we'll end up with this setup here, whereas the index of refraction of the water equals the index of refraction of the vacuum times the sine of 35 over the sine of 20.3 degrees. And I have an asterisk here because this is just will remind us that the index of refraction in a vacuum is 1.00. And that's something that we can either should know or can determine based upon the chart in the beginning of the chapter. But basically, after that, once you get to this point, it's a simple plug and chug, and for your index of refraction of the water, you retain a value of 1.65.